Alright, you guys, so we are going to go over how to draw the cosecant function. I want us to remember that cosecant theta is equal to 1 over sine theta. And so I really do think it will help if you see the connection between sine theta and cosecant theta. So because cosecant theta is 1 over sine, we know that cosecant is undefined wherever your denominator is equal to 0. And since your denominator is sine theta, it's undefined when sine theta is equal to 0. So that's one thing we want to think about when we're graphing cosecant. So we can actually look at where those values are. Sine theta is equal to 0 here, here, and here. So what I'm going to do is I'm going to actually sketch my asymptotes for cosecant for that, because it's going to be undefined on these numbers. Whenever you have 0 at sine, that's going to make cosecant undefined. So here are my asymptotes. And essentially, the way this graph is sketched is that they will share a point here, and it will fall within these asymptotes like so. And it'll just keep going. So it's like parabolas all over, okay? You'll kind of see they sort of look like parabolas. And so here they will actually keep going, squeezed in between those asymptotes. And if we even wanted to continue this pattern a little bit, right? And we have another, let's say a point here, and another one would be, sorry, that one's a little bit not there. It would be, if we want to keep it precise and exact, it would be here and also here. So you'll have asymptotes there as well. Sorry, right here. Alright, you'll have an asymptote for sine there, and then it will also share this point and continue on into infinity. Alright, and you'll see just basically a lot of parabolas. And what I'll even do is continue the cycle of sine, so you guys could see that this point will go up here, and then this one will come down here. Alright. So these green parts basically touch and fall between those asymptotes of your maximum and minimum values. All right, so the green graph is what cosecant theta looks like. So we're going to now take a look at what secant theta looks like, and that's based on cosine. And so we know that this is going to be undefined when cosine theta is equal to 0. So it's undefined where cosine theta is equal to 0. So we want to look at those points on the graph. Where is cosine theta equal to 0? I just drew a sketch of one cycle of cosine theta, and I kind of extended it on the left. So we see that cosine theta is equal to 0 here. So basically, these x-axis values, this is where cosine theta is equal to 0, and that's where we are going to draw our asymptotes for secant. So it's very similar. I'm just going to draw my dotted lines. I'm going to have my asymptotes right there because it's undefined. We cannot have 0 in our denominator. All right, so here I am now going to say, well, here it's going to share this point and create that parabola, sort of like a parabola here, and keep going in between those asymptotes. Parabolas don't actually have asymptotes. They actually go on out forever, but these are similar because they actually are stuck between these boundaries. So this point will also have something like an asymptote, very similar to, all right, I'm actually going to do another one here, just another sketch, right, if I were to continue it. So what I'm trying to get across here is it's very similar. Let's take a look back at this one. All right, so you see here, I'm going to use another color to emphasize the first sort of cycle of cosecant falls at the max here. Now, if we take a look at this one, this kind of is split in the x-axis because it's shifted over. So the same way sine and cosine are translations of each other, so are secant and cosecant. So now we're just going to take a look at what cotangent looks like, and that is based on the graph of tangent. So we know cotangent is 1 over tan, and so cotangent must be undefined when tan equals to 0. So we are going to indicate that, and that's where we'll draw our asymptotes. So it's at these points here. It's going to have these asymptotes. We're going to have an asymptote on the y-axis. We're going to have an asymptote at pi. And so the red graph is a graph of tan, by the way. So I'm using tangent as it's color-coded. And here we also have an asymptote. So now what is cotangent going to look like? Let's get a new color so that you guys can really see the difference. So I'm going to do my cotangent in orange. So here are our asymptotes, these green lines. So it's going to look very similar. It will have a center, right? So between this asymptote and this asymptote, I'm plotting the center, very similar to how tangent is. And between that asymptote, I'm going to plot the center for my cotangent. And it's going to look very similar, except it does the other direction. So I'm keeping between, again, I'll redraw these asymptotes so you guys can see. All right. I'm keeping between these asymptotes, okay? And it's going to just do the same exact pattern in the other direction with the asymptotes shifted a little bit based on the zeros.